Hello, in this video I am going to show you how to find inverse of a square root function in two different ways. Okay, square root functions are very tricky, and so sometimes one way works, sometimes the other way may work better. So I'm taking an example, and here is the example. Let's say the function is f of x is equal to minus square root 3y minus 1 minus 2. Well, this is my square root function, and I need to find inverse of this function. Okay. Now first let's try to factor the things inside the radical. So in that case we get minus square root of 3, I should have written x, right? 3x. So it becomes 3x minus 1 over 3 minus 2. Once I factor it, I know kind of transformation which will be there if we want to go from the parent function square root x to the transformed function. Okay, so the transformation is like this. If x and y are the coordinates on the parent function square root x, then they should be transformed in how will the x points change. So it is like k is 3, so it will be by a factor of 1 over 3, right? So it will be horizontally compressed by a factor of 1 over 3. So the x values will change as 1 over 3 of original x value, and this will result into plus 1 over 3, right? Because we do just the reverse of this. So it will be plus 1 over 3. Now, this is how the x values are going to change. How about the y values? For y values, we have a reflection in x-axis and moves 2 units down. So it will be minus of y value and minus 2. So that will be the change in my y value. Correct. Now what we will do is we will sketch graph of our final function, and then also do it algebraically to see what the results are. Okay. Now in this case, what are our standard values for x and y? Normally the standard values which we take are 0, 0, 1, 1, and then 4 square root is 2. We'll just go with 3 values. Then we could take 9, 3, but I think limitation of the graph, right? So if it is 0, 0, then on transformed function, what is going to be my value? For 0, if I plug in 0 here, I get 1 over 3 times 0 is 0 plus 1 over 3, so I get x value of 1 over 3. And the y value is 0, so minus 2. That is my x and y on transformed value. For 1, 1, I have 1 here, so 1 times 1 over 3 is 1 over 3, plus 1 over 3 will give me 2 over 3, right? So I get 2 over 3 for x value, and if I put 1 here, minus 1 minus 2 will give me minus 3. Okay, how about 4 and 2? If I plug in 4 here, I get 4 over 3 plus 1 over 3, so that means 5 over 3. So x value is 5 over 3, and the y value is 2 here, so minus 2 minus 2 is minus 4. So these are my transformed values for x function fx. So this is my parent function, right? Square root parent function, and that is my transformed function f of x. Now let's try to sketch this function on the graph here. Now, since you see that x values are like 1 over 3, in our graph it is good to take 1 over 3 as the basic unit, okay? So if 1 over 3 is 1, this is 1 over 3, this is 2 over 3, this is 3 over 3, that means this is 1, okay? So that is 1 for us. And 1, 2, 3, that becomes 2 for us. Is it okay? Now similarly on this side, we have minus 1 here, and 1, 2, 3, minus 2 here, 1, 2, 3, minus 3 here. Good. On y-axis, let's take similar units, and so this will be my 1, and then 1, 2, 3, this will be my 2, 1, 2, 3, okay, 3. Here, minus 1, minus 2, minus 3. So this is my coordinate system. So you should appreciate how we have taken each small division as 1/3 so that we can accurately plot our points. Okay. Now the points, first point is the 0, 0 gets transformed to 1 over 3 minus 2. So that is 1 over 3, and minus 2 is here. So 1 over 3 minus 2 comes here, right? And then we have 2 over 3 minus 3. So 2 over 3, this is 1 over 3, this is 2 over 3. 2 over 3 minus 3 is here, right? And then we have 5 over 3 minus 4. So 5 over 3 means this is 3 over 3, this is 4 over 3, this is 5 over 3, right? 5 over 3 minus 4, that means I have to go 3 more units, and that's my minus 4, okay? So let me write minus 4 here. Okay, that's my minus 4. And as you can see, the nature of the graph, it is a square root function, so it should be like this, right? So let me just connect these points for you, and then that's my function f of x. Correct? It makes sense, right? As you can see from here, if my original function is, let me kind of sketch this on the side here. If the original function is like this, let us say, right, then minus will reflect it. This will reflect it down, right? Kind of like this. And this 3 will bring it horizontally compressed by a factor of 1/3, so it comes like this, so it becomes like kind of like this, right? And then we translate it 1 by 3 units to the right and minus 2. So if I do that, so if I do 1/3 here and minus 2, so the function actually comes like this. So that's what we've drawn here, right? So it seems to be right. Now from here, this is my function. What I can do is I can transform these points and draw my inverse of the function, right? So you remember how to transform the points. We'll draw a line y equals to x. Now once we have the line y equals to x, then we can always transform. One reason why I took same units on both the sides is also because I wanted to draw a neat line y equals to x. Otherwise it becomes kind of very difficult, right? So that's my line y equals to x, right? Now I can transform these points and get my inverse function. So this is an easy way of finding an inverse function from the graph itself. So let's take, so this point is what for us? This point is 1 over 3 minus 2. So from here, 1 over 3 minus 2, inverse will be minus 2, 1 over 3. That means I go here, minus 2, and then 1/3. So this point comes here. Do you see that? That's inverse. You can go like this also. Let me show you. You can go diagonally. 1, 2, 3 and a half. Half. 1, 2, 3. You reach the same point. Correct? That's a beautiful way of doing it. Now, minus 3, 2 over 3 is my next point. So minus 3 is here and 2 over 3 will be there. Okay? Again, let me show you. It's an important thing to learn. 1, 2, 3, 4, 5 and a half. So half, 1, 2, 3, 4, 5. Perfect. So without even getting these points, I could have done it, right? Now, minus 4 and 5 over 3. So minus 4 is here and 5 over 3 is, this is 3 over 3, 4 over 3, 5 over 3. That's the point. Now to check it, we can go from here. 1, 2, 3, 4, 5, 6, 7, 8 and a half. Half, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. It just works fine. Now let's connect these points to make our inverse function. So inverse function is here for us. Do you see that? So that becomes f inverse of x. So we got inverse graphically. Okay. So now let's summarize some of the things which we discover here. Now for the function, what is the domain for the function? Now you can see here for the function I can write the domain in this ink and then I'll write inverse it. Here we see domain is x belongs to real numbers, and how about x? X is always greater than 2, right? 1 over 3. This is 1 over, let me write 1 over 3 here. So x is greater than equal to 1 over 3, correct? And how about the range of this function? Y belongs to real numbers and y is less than minus 2, right? It's going down, less than equal to. So y is less than equal to minus 2. Is it okay? So it's like downwards, right? Including minus 2. Now, for inverse function, what do you expect? You expect domain and range to flip, right? So domain becomes what was the range. So here, the domain of the function should be x belongs to real numbers, where x is this, less than minus 2. Yes, it is. X is less than equal to minus 2, correct? And the range is y belongs to real number, so that y is greater than minus 2, 1 over 3. So this x greater than equal to 1 over 3 becomes y, right? Y is greater than equal to 1 over 3. Do you see that? Do you see this flips? The domain here becomes the range there, and the range here becomes the domain there. So this is a perfect inverse function of the given function, okay? Now let's try to do the same thing algebraically and see if we can get our answer, okay? Now algebraically, what is the step? Steps are, first step is flip x and y. Let's write them in y equals to form. So y equals to minus square root of 3x minus 1 minus 2. So first step is we'll flip x and y to find inverse. So x is equal to minus square root of 3y minus 1 minus 2. Now we'll solve for y. So we'll bring this minus 2 here and say x minus 2 equals to minus square root 3y minus 1. Then we'll divide by minus 1, okay? So dividing by minus 1 will mean minus x plus 2, right? Okay, let me see. So the signs will change here, okay? So it becomes minus of x plus 2. The signs will change, okay? And we get square root of 3y minus 1, correct? Now, we can square both sides, and once we square both sides, we get, okay, so we can square both sides, or we could have written here as minus of x minus 2, it's the same thing, 2 minus x. Okay, so let me write this as square, and then we get minus x plus 2 whole square equals to 3y minus 1, correct? And then we will do minus 1 this side, so we get 1 plus. Now in the square, if we can take minus common, then also it becomes positive, right? So we can write this as x minus 2 whole square equals to 3y. Now here we can solve for y and say y is equals to 1/3 of this plus 1/3 of this, x minus 2 whole square, right? Therefore, f inverse of x is equal to 1/3 of x minus 2 whole square plus 1 over 3, correct? Now, important thing here is when we do algebraically, we shouldn't forget what our domain was and what range was. And while finding the inverse of a function, our domain and range has to flip, right? Remember, we could have found domain range from square root also, right? From the square root, we know 3x square root, that thing in the radical should have been positive, right? So we could have said 3x minus 1 should be greater than or equal to 0, right? Or 3x should be greater than or equal to 1, or x should be greater than or equals to 1 over 3. So we get our domain straight, correct? And range is, it's going downwards, that minus from minus 2. And therefore the range is, it is below minus 2. So when we say inverse, then range becomes domain. So range should become, domain should become less than minus 2. So here we are considering the quadratic function where the value of x should be less than or equal to minus 2. So we should put this restriction here, because you know what, whenever we do square root or square of a function, we actually incorporate errors. Because what we done here is we made negative also positive. So there are two possibilities of this equation, right? I could have written this as, to be very clear, let's see what I did. I did here like this. I wrote minus common and then x minus 2, right? And this was whole square, correct? So when I square it, this minus becomes positive, and therefore I wrote x minus 2 whole square. Do you see that? But there was minus, right? So it could be either side. Well, we have corrected this by having a prior knowledge of inverse means domain and range will flip, and therefore this is a very important condition to put on our inverse. Now only this is inverse of the previous function. If we don't, and if we use both plus and minus values for x, then it doesn't work, okay? Because we don't have the upper half of this, right? Which could have been like this, right? We are only considering this half where x is less than minus 2. Therefore, this is a very, very important step for us. I hope you agree with me. Now here, if you see, this is a parabola whose vertex is at minus 2, 1 over 3, right? Minus 2, 1 over 3, correct? And we are considering x values on the negative side only. Therefore, it's this half of the parabola, not the other half of the parabola, correct? It is a very, very important thing to keep in mind, okay? So, until and unless we write x less than or equal to minus 2, this really does not represent inverse of our square root function, okay? Keep that in mind. Review this. This is a very important example and kind of difficult. There are so many places where you could go wrong. One, the very first place is right here. When you're given a function like this, you should factor 3. And once you factor 3 out, you get x minus 1 over 3, and then you write your transform points. Otherwise, you will think as if horizontally compressed by 1 over 3, but you will add 1 instead of 1 over 3. That will make a huge error, correct? Second, when you start, you could have started from here, checking your domain, right? This is a check domain area, correct? Within the radical square root, you should always have a positive value or 0, non-negative I should say. So in that case, 3x minus 1 should be greater than or equal to 0, 3x is greater than or equal to 1, and x is greater than or equal to. As far as range is concerned, range is easy to find. It is flip on x-axis, so it's going downwards from minus 2. So y is less than or equal to minus 2. So you can check from here. Finally, when we got our points, well, as expected, we got a graph, and this was good enough. So it's a kind of a check. So we have multiple checks in place to ensure that what we are doing is perfectly fine. I hope you understand both the methods, and both are equally good if not specified which method to use. So this is a graphical way of doing inverse of the given function, and that's the algebraic way of doing it, okay? Don't forget to write this restriction in the domain, okay? Thank you.